Hello, this is Brother Cromer from the Math Department at BYU Idaho, and this is a continuation of the videos dealing with inference for bivariate data. So now I'll be talking about hypothesis testing, and I'll wrap it up with confidence intervals. So first with hypothesis testing. So here is a true regression equation where we have y is equal to beta naught plus beta 1 times x plus epsilon, where beta naught and beta 1 are the parameters, and beta naught is our y-intercept and beta 1 is our slope, or our true slope, and or epsilon is the normal random variable. We are mostly interested in the parameter beta 1, which is our true slope. So therefore, because of it, we state our null and alternative hypothesis as such. So we state the null is that beta 1 is equal to 0. What that means is that if we were to create a scatter plot and draw a line on the scatter plot, the line would be a flat line. Would be a flat line going, it's a vertical, or a horizontal flat line. Okay, that would be where our slope is equal to 0. Our alternative hypothesis is that beta 1 is not equal to 0. And if beta 1 is not equal to 0, then we can say that there is a linear relationship between the response variable, the y variable, and the explanatory variable, the x variable. So here are the 6 steps for doing hypothesis testing for bivariate data. Step 1 is state the null and alternative hypotheses, and here they are. Steps 2, 3, and 4 we use either Excel or SPSS, or test statistic, degrees of freedom, and our p-value. And then the last 2 steps are the same last 2 steps that we've done throughout most of the semester. So reject the null hypothesis if the p-value is less than the level of significance, or alpha. If not, then don't reject. And state the conclusion in layman's terms. If we reject the null, we have sufficient evidence to say that. Then we state the alternative in English. If we don't reject the null, we have insufficient evidence to say that, and then we state the alternative in English. Okay? So now, here's an example with the crocodile data. So the first question is there a linear relationship between body length and head length? We can use a level of significance of alpha equal to 0.05. So step 1 is state the null and alternative hypothesis. So the null is beta 1 is equal to 0, meaning that the true slope is a horizontal line, it's flat. And the alternative is that beta 1 is not equal to 0. Where we get the remaining steps, not the remaining steps, but steps 2, 3, and 4, we get it from our Excel or SPSS output. So either way is fine, or you get the same results whether it's Excel or SPSS. And so we have our test statistic we get down here, which is 35.588. By the way, the bottom row for either Excel or SPSS always represents information for the slope. The top row for this type of chart represents the information for the y-intercept. Okay, so going back to this here, I got to move this down here a little bit, and that is that our test statistic is 35.588. Our p-value is close to 0, and our degrees of freedom is where we get it up here in our ANOVA table, which is the line under the residuals. Our degrees of freedom would be 26. So since our p-value is less than alpha, since alpha is 0.05, we reject the null hypothesis, and we have sufficient evidence to say that beta 1 is not equal to 0, meaning that we have a significant slope. Therefore, we say that there is a linear relationship between head length and body length. Okay. Here's another example. Is there a linear relationship between manatee killed and the number of powerboat registrations? Use a level significance of alpha equal to 0.05. Here's the null and alternative hypothesis, like it is and will be with every other problem with bivariate data for this class. Where we get these next 3 steps, test statistic, degrees of freedom, and p-value. Here's where we get our test statistic. It's under t, 15.491, and our p-value is close to 0. Okay. And our degrees of freedom is where we get it under the ANOVA table, and it's on the residuals row, degrees of freedom, and so that's 33. So since our p-value is less than alpha again, we reject the null, and we have sufficient evidence to say that the slope, the true slope, is not equal to 0. Okay? Therefore, we can say that there is a linear relationship between manatee killed and the number of powerboat registrations. Okay? Lastly, I want to talk about is confidence intervals. Okay? So the confidence interval, so this is the true regression equation, y is equal to beta naught plus beta 1 times x plus epsilon, where beta naught and beta 1 are the parameters, and epsilon is a normal random variable. We are mostly interested in the parameter beta 1, which is a slope. When we create a confidence interval, we say that we are X% confident that the true regression slope, beta 1, is between the lower limit and the upper limit. The other definition that you've seen throughout the semester is if we were to do a confidence interval a gazillion times, and if we say we want to do a 95% confidence interval, we would be able to capture the true regression slope about 95% of the time. Okay, so here's a couple of examples of it here. So here's with the crocodile data, and this is where, because we're dealing with the slope here, we want to get these two numbers for our confidence interval. And so because of it, we say that we are 95% confident that the true regression slope is between 7.218 and 8.103. Just like with when we dealt with two proportions, matched pairs, or independent samples, we'd like to see if 0 is in this confidence interval. Since 0 is not in the confidence interval, we can say that the slope, the true slope, is not equal to 0. Okay? And with the manatee data, and this is where we get our information down here for the manatee data. Since we get this result here, we say that we are 95% confident that the true regression slope is between 0.112 and 0.146. Since 0 is not in our confidence interval here, we can say that our true slope, beta 1, is not equal to 0. And so that concludes the videos dealing with inference for bivariate data. So if you have any questions, please speak to your teacher or to one of your TAs.